So the first session of the last day of this Material to Manufacturing 2021 is by Dr. Amar Patnaik. Dr. Amar Patnaik is currently an associate professor in the Department of Mechanical Engineering, MNIT Jaipur. He did his bachelor's from REC Karnataka and MTech from NIT Rourkela, and PhD is also from NIT Rourkela. So just now I came to know that sir worked at NIT Hamirpur also. I was of the opinion that he started his career at MNIT Jaipur. So Professor Patnaik has worked about 5 years at NIT Hamirpur. Then he is shifted to NIT Jaipur. So if you see his lab now, it is like an international standard actually. When you go to his lab, you don't feel that you are in India actually. So such a large facility he has established and a huge number of projects, and he's almost having 10 to 12 PhD students all the time working in the lab. So the lab, when I went at night, 11 o'clock, still people are working. So that is the culture which sir has developed at MNIT Jaipur. Professor Patnaik's basically his area of interest are composite materials. Recently he started with biomaterials, metal casting, and tribological aspects. He is a pioneer in tribology in the country. And with these few words, sir, I request you to share your experiences with the audience. So you are given 1 hour 15 minutes, sir. So then we will have 15 minutes discussion. And after the session is over, we will take a photograph with all the participants along with you.
Okay, sir. Thank you, sir. Thank you, sir. Is it visible, sir, that slides?
Yes, sir, it's visible.
Okay, okay. Okay, very good morning to all, and it's my great pleasure to be a part of this international conference. So today I have this month's plan to discuss about the biomaterials, specifically biomaterials. It may be any type. So we are working in our laboratory that hip prosthetic materials and as well as dental materials, both we have, and we have broad facility of both hip as well as dental materials. We have dental simulator. Today I'll try to discuss both the parts so that you will come to know that what facility we have and how exactly it is working with the human body also. That is the most important part. And specifically this biomaterial is a very complex phenomena that development of a biomaterial, it is nowhere in the world people can say that it is a perfect biomaterial. Till now we don't know what exactly the real biomaterial is in our body also. Lot of people have lot of comments on that, but it has a lot of new every time. So if you go through it, comes something new materials only. No doubt it is a ceramic. People are saying it is a human body. Whatever the materials are there, it is a ceramics only, but has a complex still that. So the biomaterials, why it is important? First of all, think is that the most of the joint applications they are facing is a major problem is that either it's a side effect is there or the materials fails in between, or you can say that there is some mechanical failure is also there. So failure may be anything. Failure may be because of the materials or because of the technique, what you have fabricated, or because of, you can say it's a life, or because of the side effect. Because the reason is that biomaterials, one specific biomaterial, we can't fit to all bodies. So it varies from person to person. So it varies from one human being to another. It also varies from age group is also there. So it is a biggest issue present day that, and we are also doing some basic works on these biomaterials. Today we'll show you that few things. So joining of this material is the fastest. You can see the right hand side the figure that the joining of the materials. So the prosthetic materials is exactly, it's a three part only. Anyone can damage or all can damage. either the stem, that is acetabular liner, or between that the ball is there. So the failure may be any part. It may be the liner, it may be the ball, it may be the cup also. So this is a some means the generation of the biomaterials is maybe polymers people using, their ceramics also using, and the metals and metal alloys are also using. So the last we can say that every year, as far as American Academy of Orthopedic reports, they are saying that every year you can say that nearly 1,93,000 we are replacing, and nearly 1,40,000 is the partial and revision of hip replacement. So it is a common problem every world. It's not in India, or it's not some other countries. It's everywhere is there. Only we have that record. That's why we are showing it to you. So we'll see that how it works, and what exactly the biomaterials and where it was started. It is not specific to some area, mechanical, or it is a medical science only. It's all. It's a science, arts, commerce. Everything is under these groups only. So we are saying it is a that it is 1987 that there are few pioneers, Williams. The first they have developed through medical devices. It was not developed previously. It was developed, but some effective results are there during that period. Because of that reason, we can say that it is the effective period of analysis of biomaterial is from 19 to 87. And it's a main the biomaterials. The problem is that materials failures, as I said just, or it is a prior to that material some natural man-made also people have used as a artificial replacement materials in a human body, or it may be animals, anywhere it is. So the really the any biomaterial we will use it, and we need to study few things first. Otherwise, we can't use it directly in body or in direct any applications. It may be any, it may be a human, it may be animal also. So the prosthetic replacement is feasible in both human as well as animals also. Research is going on both. In India also, both we are doing. It's not only human beings replacement is there, it is also replacements in animals also doing. Sometimes we are doing animals depending upon what our cultures affects. We are least bother about animals, so there is a less replacement, but human being, is a major replacement is going up. So near to my MNIT, there are a big production house is there. It is a private laboratory is there, and they are developing the biomaterials through polymers only. And so how can you say our biomaterial, the material whatever you have developed, and we need to study its compatibility first, whether it is a biocompatible or not. That is the first analysis. So while studying of the biomaterials, I will show you that how people are studying through different putting the material, developed material in a animal's body, and they are testing the compatibility, and through equipment also you can study both. But the biocompatibility generally it depends the type of materials and the type of stresses also. What type of, because it purely the prosthetic it depends upon the load also. Load is also a major concern that. So that there are few mechanisms of material degradation. It may be take place corrosion, or it may take place some chemical modification, swelling, leaching, and wear. These are the common. And my part is the wear as well as corrosion. Rest part we have not covered, and it's not our area of research only. So the prosthetic materials, the material, the developed part, that is the artificial part. Any part can replace also in a, and people are studying, but our part is only the liner part only. So exactly the area of research what is going on in a present day is all Depending upon the situations, we are using the materials. Either you can go for metals or you can go for metals and alloys. We can go for ceramics and also polymers. So in a metals, the use is measure. Reason is that it is in between. Its application is nor it is a weaker or it is a stronger material. So it is in between polymer and ceramics. So the basic biometal what it is using in a metal is a cobalt-based alloys are the basic and titanium and its alloys. Stainless steel is the oldest fashion that people are using. As far as ceramics, alumina, zirconia, bioglass and glass ceramics, calcium phosphate ceramics. So it is a group is there. And as far as polymer is concerned, UHMWPE, that is ultra high molecular weight polyethylene, that is the measure using. Most of the you can say medical, they are using this metal as a membrane materials also, sometimes as a cork material also, sometimes as a liner materials also. UHMWP. It is like the behavior is like metals only. So as far as application is point of view, it is good and corrosion resisting materials. It is. So the in before going to our results, some basic things we want to refresh that things. So it is the peoples are working on material scientist, biomedical specialist, pathologist, and clinicians. So all are working on this year, this particular the area of biomaterials. And one of the example I want to say that AIMS Delhi, they proved that whatever the biometals we are using, it has side effect. And this article is available on online AIMS websites. So it means that it is still there is some defects is there, or you can say maybe casting defects, or it may be side effect of that, because it's a side effect means it is a major side effect is it is a cancer. That is the major side effect. Other side effects we can measure it, we can manage it also. But as a cancer is the one of the, you can say that the highest degree of it is more than COVID also disease. So the biomechanical compatibility, biocompatibility, high corrosion and wear resistance, these are the minimum or basic study any materials if you develop as far as a biomaterial for either for prosthetic or for dental or for some other applications, specifically for bio applications, you have to study these things only. So the research has started from you can say that some 1938 also, and first of what biomaterials they've used, it is a M&O, that is a metal on metals, so stainless steel cup with a head. So because as I said that a cup is there, then liner is there, and the ball is there. All the three are important. Any of the component related to the fail, then it is a biggest problem. It is the biggest problem because second time replacement again it's a tough and it is a tedious to patient also. So then it has some failure also that makes that part the cop was fixated using screws and some heads was used. And the demerits we will discuss again that in 1958 also another group they discuss on metals and polymers, because all the parts, so we no need to go for metals only. And if because they feel that there are one or two parts, if you go with a polymer, then the weight can be reduced, and maybe some good properties also. It's not a bad thing. So because of that reason, this partially replaced metals and they used as a polymer. So it is a PTFE, that is a polymer. It is a very good. And what they have observed that the rapid wear of the PTFE is there. So after means using of that particular materials, then they come across that, because the things what you will study in a laboratory, it may not be same as in a real life analysis. It is slightly there is a variation is there, because in a laboratory whatever you study, specific boundary conditions, we'll put it and we'll study that one. Maybe the load is 50 kilonewton, 50 Newton, or maybe some other loads will, or the distance some specific. But once it will work in a real life, every time, every moment, it will vary also. Then again, 61, and there are another biomaterial that they've replaced, that is ultra high molecular weight polyethylene, that is UHMWPE. It is a low in friction against a metal, and you can use it as a low friction material of this particular, this specific, this material. Then ceramic on ceramic, that is the prime year of biometal is that ceramic on ceramic, because it is a very tough, first of all, to develop the specific materials, ceramic and ceramic, because ceramic material further machining, further change of its design is not possible. Once you change it, then it's a failure. You will see the failure of that ceramic material. So you have to cast directly, whatever it is, direct. You can use it, just a simple polishing. After that, you can use it. So that is the major problem part of ceramic, but it is very good in wear resistance, and even you can get it a better surface finish also, specifically ceramic materials also. But use of this ceramic materials is very less, very less. So there are different the hip joint replacement. There are huge number of combination of materials are there. I don't want to read all these things, and if possible, I can share the slides. You people can see also. Just it is a so problem in the biomaterial is these are the basic problems are there. Is there infection or dislocations or some other, or is a aesthetic loosening? It is a 64% is the major part is there. Infection is 16% and dislocation is 10%, and other causes are also there. That is at nearly 10%. It is the study of world study. Biomaterials generally the failure part is the measure is the aesthetic loosening is the measure. So all these sportsmen, even sometimes if you jump or dance or like this, there is sometimes there is a slip of disc or slip of hip, or these materials are there. So the measure is the 64%, and let the material has some side effect. That is the infection, we can say. And dislocation is again a part of this study. And uh, so the area of research is big, and the area of defect is also big. It's not a very small, it's a very broad. So you can say that because 64%, how can you identify it? It is a big things only. So the people, how they've used the different group of ceramic materials, and these are the different series of ceramic materials, and every series has some merits and demerits is there. Let I want to use it, that is aluminum zirconia series of I want to use it, then you can say that is the impact resistance is good, somewhere wear resistance is good, somewhere it's you can say that corrosion resistance is good. So and you can't get all these properties in a single material. That's why you can say that as a material, it is a versatile in character only. We can't get it everything in a materials. So if you will get everything in a all the property, good property in a same material, then you can, then there is no need of further study. So that's why there are every elements of materials have different role. It maybe someone is very good in resistance, someone is very good in, you can say that the corrosion, someone is very good in wear. So there are different applications are there, different materials is. So just I have written all these things, and the generation of the biomaterials, that is 1974, that first generation of biomaterials. And here 100% of theoretical density, they've what they have calculated, and what they've observed that the reduction in strength and contributed to the earlier failures. Earlier failures are there. So second group of the second generation, 1992, they just improved the materials. They just improved the materials with a finer grain size, because the size of a particles and the surface finish of a particle, it also depends directly the strength of a particular material. So that's why they just changed the, maybe initially it was a macro, then it's shifted to the micro. Present day, almost all biomaterials people are working on a nanomaterials only. So the effect of size and its surface finish is also a major role. That is the second generation. What they have observed that the raw material with a finer grain size is required and lower level of impurities. That these two things they have identified and they've used. And the third generation in 1995, what they've used that they slightly changed the technique of fabrication. It is by hot isostatic pressing after sintering the reduced grain size. They've used it. It is a technique of fabrication. Either you can go for steel casting technique, or you can go for powder metallurgy principle, or someone can go for centrifugal casting, or you can go for compression molding. So there are similarly hot press is another technique, is that at a controlled pressure and temperature you prepare a specific material. So it is one group of research. That's why it is a generation that first, second, third, how it's changed slightly. Then the fourth generation, what they identified that alumina matrix composite with 82% of alumina and 17% zirconium oxide, 0.3% chromium oxide, and 0.6% strontium oxides they've used. And they observed that the property, whatever before the three generation, first, second, third, slightly better as the hardness improved and the wear resistance also improved. And by using chromium oxides, if you use strontium, then there is a use of the enhance of toughness as well as rock energy. So that is the fourth generation's identification is there. So it's only these generations. So based upon that, the following materials people have developed, and they have identified that these are the different groups of materials are there. So the main of this these three series we have prepared nearly, you can say that 16 to 17 series. Nearly five students they've already completed hip prosthetic, and four students nearly they've completed the dental material. So we have huge number of series. This is the one of the series, and that is three series we have prepared. And first series is the basic what people have used. That is a cobalt, chromium, and molybdenum series is there, and some weight percentage as per literature we have changed. And the second series, what we observed that we want to include some nickels. That is the second series one. And third series, along with nickel and molybdenum, we have used tungstens also. These three. Then finally, we have observed that which series gives better. So almost all the studies we have observed, and we have studied. So only one series we will discuss. This is our biomaterials part, as far as we have casted these centrifugal casting machines, and this is the grinding and polishing machines. This is the micro hardness machines, and you can say that scanning electron microscope and XRD, FESM we have. Then pin on disk, it is at our laboratory in a high temperature. Pin on disk temperature, it is a lab testing equipment. And atomic force microscope is also in our institutes. And corrosion analyzer we have also. And tissue process, we have studied some different laboratory in MNIT only. So these are the equipments what we have used, we have studied in our work only. So one of the series I want to discuss is that if as far as biomaterial is concerned, and I want to let you think it that I want to use it, my prosthetic material in a particular application. So I need to think that that particular persons at what velocity you want to travel, and what is the load of that particular replaced persons. So these are the basic boundary conditions are there. You can go with the load and velocities, distance, as well as the content of the materials. These four things we have taken into considerations and we have studied. So load up to 25 newtons and sliding velocities also we have taken from 0.26 to 1.30, and the sliding distance from 500 to 2005 meter. And after that, you can extrapolate. It's not a big thing only through machine learning technique, or you can through GA or through artificial neural network. We can extend that. We can change the data, and we cannot necessary to do everything through experimental only. Some soft computing also we can analyze the things very well. So these are the few basic studies we have observed, that few basic that through XRD as well as its EDX analysis also we have observed. And here the cobalt chromium, these materials, and molybdenum. This is the series cobalt, chromium, and molybdenum. And molybdenum is a filler material, just 4% we have added, and the rest all the base materials, that is the cobalt and chromium. Through XRD, what we have observed that there are these 5 series of the materials are there. So in XRD, we have observed some oxides also, formation of oxides are there. So the formation of oxides, because it also indirectly affects the failure of your materials, the oxides. That is also required, means to identify whether the during casting any oxides is formed or not. The reason is that if oxides are there, then obviously there is some type of a cracks or pores or the voids we will observe once it will start working, because few of the cracks or the voids, it is internal only. We can't see in our naked eye, even microstructure also we can't see it. But it is invisible like structures are there. But once you will apply the load, the boundary conditions, and either load or distance or the velocity, anything, some boundary conditions we will apply, then we will come to know that these are the type of failures are there. So where there is a crack, where there is a pore, or there is a porous like structures are there, so there only the means a crack will generate, and it ultimately it will reach to fracture only. So it is a major failure of the major casting failure. It's not some other. It is a major casting failure. So these defects also we need to identify. So these defects only we can reduce it. We can't avoid it. Obviously, the metal or metal alloys, such type of a oxides, you will see it here. So the oxides may come from externally, because you have prepared the composite in open heart furnace. So it may come externally, react with cobalt or chromium or molybdenum. Then you can form it is a COX and CRY. So the X and Y is the maybe 2, 3 like this only varies. So through this we can see that if the percentage of MO is varies from 0 to some other level, then you can see that cobalt, chromium, molybdenum, and oxide, cobalt, chromium, oxides, cobalt, molybdenum, and oxide, all type of combination of oxides, we will see it here. Or the oxides may come also from CO also, it may come also, because we have to heat the material so that it can you can cast it properly. So generally in a casting technique, we have to heat that material up to certain temperature. So if you heat it, either from CO the oxides comes, or it will come from, you can say that external environment only. So these things we have observed through XRT. Simultaneously, the micrograph also, through scanning electron microscope also, we have observed that the formation of means the availability of a cobalt, chromium, and molybdenum. Through EDX, it is one of another parallel analysis of microstructures. So whatever through microstructures you have observed, through EDX also we can see that as I have used X, Y, Z, 3 materials I have used, and all these 3 are available or not, or they are in the form of the same what virgin material we have used, cobalt is there, or chromium is there, MO is there, or something else is there. So that also we can observe through EDX analysis. And this is the different micrographs as well as their index analysis. You can see it also. So this is a one of analysis. And through other part also we have studied its density, hardness, as well as the compressive strength. We have observed that by using 4 weight percentage of MO, the hardness is is quite high as compared to the 0% of it. The increase of hardness, is only one major advantages is that the filler materials, whatever we are using it is harder filler materials. Because of that reason, the hardness is improved. Simultaneously, casting is also good, no doubt. And the seat compressive strength, because if we use it, our material as a dental material or our material as a prosthetic hip applications, compression load is a measure. Nobody will go for tensile. Nobody will go for tensile. It is. So it may be compressive or it may be sudden impact test. It may be a fracture. These three mechanical tests generally people are doing. So these are the results, and by seeing the results, we can say that by using the because why we have reached up to 4%, why not it is a 6 or 5 or something? It is a big question that we have studied that also. If you go with the next level, then starts showing inferior of the results only. So this is again another series of that materials that if you see it here, cobalt, chromium, molybdenum with another series of that, it's a nickel, next group of that. Here also we have studied all these XRTs. You see it here, by increasing the percentage of nickels, then we are seeing that nickel oxide, cobalt, chromium oxides, like all the oxides are there. It means it is our the beginning of our bio study is this one, this results only. And I didn't like to show you the last result. Reason is that what exactly the failure is that we should know faster. Then next level of biocompatibility bio study if we do, then we can go with the next. Because in the initial we have studied with a casting technique, then we have studied with some other laser plasma sintering technique only we have studied. There we will see that 0%, zero we can say that nearly, except few one or two cases, otherwise nearly 0% of formation of oxides are there. So this is so, and their results, what you have observed that here you see it here, the zero is what, cobalt, chromium and molybdenum is a 0 and 4 weight percent of molybdenum, as compared to that 4 weight percent of nickel shows inferior as far as hardness is concerned. So through this only we can see that, because all these series we have fixed some percentage, then we have shifted to next. Again we have fixed some percentage, then we have shifted to the next, so that we can compare it one by one, that which series shows better, which series is inferior results only. So then again shifted to the third series, what you can say that cobalt, chromium, molybdenum, nickel, as well as the tungsten is the last. And simultaneously all, we know not a single test we have missed in our analysis, that all tests we did it. And here also we have observed that the oxide formation is also a major issue in this. And the color through microstructures, it is we need to study more, that if a cobalt is there, what should be the color? If nickel is there, what should be color? If a molybdenum is there, what should be the color? If tungsten is there, what should be the color? That we should learn through different books as well as different papers also, so that we can easily identify that exactly what are the materials are available in our C, any of the microstructure, either A, B, C, D, C. Let us go with the C. Then we have cobalt. We have cobalt is there. We have chromium is there, and all we can see it. The part rest few things we are not. It's not possible with the microstructure C. So for that we are doing XRT, EDX. Through EDX also we have observed that all are there. See EDX side just right that we have seen that the EDX, through EDX we have observed that cobalt, chromium, nickel, molybdenum, tungsten, everything is there. So these are the analysis is there, and it's physical and mechanical properties of this. And The main is the wear analysis of our part. So we have studied that both dry and wet conditions. Dry we are not using because if it is a acetabular liner or it is a cup or if it is a cone, anything, generally the cup and cone part, there is one type of a liquids is there. So it has different applications for the role of liquid. It will work as a lubricant first of all, and it maintains also temperature also. That type of a liquid, it maintains, that is the god grace God has given, that it maintains that temperature also. Why temperature? Because once it will rub to each other, then you need to maintain, otherwise the metal will fail. So it is one type of artificial. We have used artificial type of liquid, that is artificial synovial liquid we have used, and we have seen that for the different loading conditions with the change in velocity, with the change in load, all we have seen it is. And in a dry as well as in a wet conditions, both we have observed that simultaneously friction is also a major issue. If more friction is there, definitely there is a failure. It's 100% there is a failure is there. So that also we need to study that how to reduce that friction. So, but nowadays people are also using without using any intermediate thin layer, that is type of a lubrication layer. Without that, we are using inbuilt type of materials so that it will give a self-lubricating behavior. So generally in a brake pad applications, people are using graphites also. It is a self-lubricating materials. If it starts burn, means starts rubbing, then automatically lubrication will generate for instead of some specific time period, it will generate so that the material will not damage. So through this, the dry conditions, what we have observed that the dry as well as wet, both the conditions we have observed with respect to change in velocity and with respect to change in load, both the conditions that the 4 weight persons wear is 4 weight% in a wet and 4 weight% in both dry and means sliding with change in sliding velocity and change in load, both the conditions we have observed. Same, it's the coefficient of friction also we have calculated. So for all these, and these results are means machine given. It's not we have taken some data and prepared. So the same data what we have collected through the pin and disk, the same data what we are showing here. So the means the velocity as well as load, as far as our facility or otherwise 25 Newton is not a major load, we can say. It may go up to 130, 150 people have studied, but facilities as per facility, but basic loading condition is up to 25 Newtons only. Almost all the papers they have studied this. So similarly, the design we have used that because it is a very costly means technique, because even biometal first of all is a it's not that huge money we need to spend to prepare or to test all these things. So some design of experiment we have studied that so that with a limited number of experiments we can get better results, and we can justify also that our results are good as compared to good or bad. It's a different issue, but the thing is that with a limited number of experiment we can reach that conclusion. That is the majority. So in a graph A, B, C and D, these graphs what exactly indicates that by using this design of experiment, it may be you can use the Taguchi design of experiment or you can use response surface methodology. Both the design of experiments you can use it, but what exactly it will help you that the particularly if it is a load you are using one input or velocity or distance or it is a contents of the filler. So individually I am sure that the velocity is a major impact velocity or the sliding velocity or the sliding distance or the load, they are the significant factors. I am sure that, but at what a value, exactly at what value it is significant, that is most important. So as far as in figure A, we can say that at a load, as far as load is concerned, the 20 Newton load gives a better result. 20. Similarly, for velocity, if we'll go with a velocity, sliding velocity, then 0.26 meter per second gives better. Similarly, as far as distance is concerned, 2500 meter distance gives better result. Similarly, as far as filler is concerned, that 1 weight percentage of that particular filler gives better result. So in future, anyone will do research on the specific series, he or she no need to go with all these combinations. Exactly this combination A4, B1, C5, D5. This combination we should start first. Then it's higher. We no need to go for again from root that 5, 10, 15, 20, 25 load. I no need to take in the future. That's why literature review is also one of the why we are saying that without literature review, any analysis is not that much of fruitful. Reason is that through literature we can get exactly that at what combination we need to study. So that will help you that if I will go with this combination, or I can go with some other different combinations. So this is the best combination in a particularly some as far as parts wear is concerned. Similarly, we can say that in a both dry and wet conditions are there, because A and B, they are the dry conditions, and C and D are the wet conditions. In a wet conditions, the result is slightly different. It is in dry condition, if load is 20 Newton, in a wet conditions, you can see that 5 Newton load is it means gives better results. So similarly, the velocity 0.523 meter per second. As far as distance is concerned, 200 meter, as well as filler is concerned, 4 weight percentage gives better. So this is the difference between dry and wet conditions analysis only. But in reality, real analysis is the wet conditions only. But we have studied both dry and wet. Reason that not necessary the material whatever we have developed will go for only prosthetic applications. We can go for some other applications also. It's not. It is a biocompatible. It is a biomaterial. So it is not that sense we can use only bio. We can use it some other applications also. As a cobalt, chromium, molybdenum, vanadium, or tungsten, or titanium, they are using some other applications also, because they are good property materials. They are good property materials. We can use it some other applications. Because of that reason, we have used both dry and wet conditions, so that we can find out some new applications by using the same material. Okay. Because of that reason, we have used it. Similarly, we have studied some statistics part. It is a pure statistics part. Here, what the percentage contributions of individual factors we have calculated, and what we have observed that the specifically the distance is shows as well as the velocity that shows significant. So these two comparisons we have observed through statistical analysis only. Then after that we have studied its surface morphology as well as through AFM, that is atomic force microscopes, also we have studied. And here you will see that the means all these zero weight percentage of MO in different boundary conditions, 1 weight percent of MO different boundary conditions, 2 weight percent of MO different boundary conditions, 3 weight percentage, similarly 4 weight percentage, all. Only we have changed some percentage of the materials and applied same things, and see we have seen that what type of failure, somewhere the removal of matrix is taking place, somewhere some type of a swelling is there, or that there is a micro crack is there. These are the these are the wear means through wear we can observe these type of terminologies only. Okay, and through that we can further predict that how can I change my materials. If there is a removal of matrix materials are there, it means the matrix is weak. If there is some type of a micro crack is there, it means that the filler whatever we have added, it is not mechanically compatible, or bio it is not compatible. So similarly, there is a, we can say that a failure of like a plowing type is there, it is a micro plowing is there. It means that the filler as well as the matrix, the bonding is not strong. Okay, so the interface zone always there is a failure is there. So because of that reason, this type of analysis we have to study faster, so that we will come to know that what we will do the next. Simultaneously, we have studied atomic force microscope. Here, in atomic force microscope, we have observed the surface of particular materials that after tribology analysis, through surface roughness tester also we can do, but through atomic force microscope, we can get more accurate of these things. Means let it will move from one end to the another end, how the surface peaks. Through the surface peak, I can say that my particular zone has the wear is more, that particular is wear resistance is high, that is, it may be the filler that particular zone, or it may not be that, or it may be the incompatible combination of that materials. So that things we can calculate it, or we can understand it through the atomic force microscopes, and the line profiles of the molybdenum field, cobalt chromium alloy composite under dry, similarly under wet conditions also we have studied both. So through this peak, I can say that my material is material, the uniformity of the filler distribution on the surface of a material is not good. It means that. Otherwise, what you can get a straight line, you can get a single straight line. Instead of that, a multiple number of peaks, we can't see it here. There is up and down, there is up and down. It means that these compare the, maybe the arrangement of fillers is not uniform, or there may be incompatibility. The reason is that we have studied both. If it is incompatibility, then what to do, and it is not uniform. It is not uniform is in general, because as we have studied through stir casting technique, it depends that how many time or how many time number of times you have stirred the materials, because as it is in high temperature, it is very difficult also to do this job. So it, but ultimately we want a product which gives better results. So through AFM, atomic force microscope, we can observe these things also, that how the uniformity of a materials is on the surface is there. Only on the surfaces first is. Same the other groups of these materials, that here what we have observed that in a dry as well as in a wet conditions, with the 2% of that nickel. And as far as loading its conditions, 2% dry conditions gives more wear, means it is more wear, whereas the other, as compared to that, I don't want to say that all are good, as compared to that, rest are good only. So only so through that, we can say that in next future analysis, we should avoid that also. We should avoid that particular percentage of that. And through analysis only you can see that, otherwise it's not that easy to predict that which combination, because there are nearly 10 combinations are there. So without studying anything, we can't say that this specific condition is good or not. So these are the, again, another series. I don't want to repeat the same thing. This is another series having different combinations of properties. So this again same. And here what we have observed that the C, that is what C is, that is sliding distance is more important. That is sliding distance is more important. With increasing, means it sliding distance directly it depends on the life of that material also. How much a person is a sportsman, its sliding is different. If a person is a common man, if a person is in a heavy means a heavyweight person is there, or is a lightweight person. So it all depends upon the distance and load only, these things. Similarly, it's a atomic force microscope as well as the scanning electron microscopes we have observed, and it's a wear analysis of that materials. That here we can say that 4 weight percent of W is goes, means more wear as compared to other, like 2 weight percent of W shows better wear resistance as compared to, as far as volumetric wear is concerned, with change in velocity. And similarly for loading conditions, 2 8% of that is also give, as well as same how wear we have calculated similar frictions also. This is another series of materials we just skip this part. Another series of materials, same, it's a surface morphology we have calculated, and I want to show you that how other analysis also important, as I've discussed that particularly the biomaterials, it's purely depends upon the materials property, it depends upon the corrosion resistance, it depends upon the wear resistance, it depends upon the types of casting technique, it also depends upon the types of materials, it also depends upon the size of shape of the material, size and shape, all these things. So you can see it here that the electrochemical test through what exactly this study will help you that through this specifically the electrochemical test is there, since the corrosion current is generally it is directly proportional to the corrosion rate, and if you see that the lower corrosion, if you say current is there, then better is the resistance against the corrosion. So this through electrochemical test, we can identify that which is more corrosive material, which is less corrosive resistance material. All these series are given in at a time in one. So through that we can see that through in a tabular form also we can see these results, the corrosion analysis of the results, and here through this we can say that exactly which material will give better suitable to the human body, which is less. That is the most important, that as by definitions itself that corrosion of implant implies that a certain amount of ion is released from the implant material into the body. That is the basic definitions of corrosions only. So here this by using these combinations, specifically the corrosion rate is high, so 0.8% of MO. In the second case, the corrosion rate is the 0.8% of nickel, or in the third case, it is you can say it's a 4.8% of nickel, 0.276 is the corrosion rate. So through, because it is the basic analysis, is that beyond that it is means we never use any paper on biomaterials. If you want to submit in a journal or in a further patent, all these things, we have filed a patent also through that. It is in examination stage. We received already in a first examination report FER, and hopefully it will grant, because the materials whatever used, it is 100% proved that this material is a biocompatible and it is suitable for specific group of human, specifically 25 to 45 age group is suitable this particular materials. Beyond that it is not possible, below that also it is not possible. That also we have studied. I'm not showing that part because we have filed a patent of that part. So it is a biocompatible study. We have studied in a laboratory, in a DRDO laboratory, one of the DRDO laboratory, and this is Amar Patnaik. The hands, what you will see, it is Amar Patnaik only. We have studied, they have given some training to us, and then we personally did these things only. So it may be rabbit, or it may be the horse also people are studying. So it depends. It depends as far as their facility is there. So what exactly they are doing, that we need to understand that the materials, once whatever material you will say that this is my final material and it gives better result as far as biocompatibility study. So you need to study first it's inside the animal body, because we are clever, we never use in human body, so we are using as a animal's body, and it is illegal also. We can't do it in our laboratory, it is illegal. So some means authorized laboratories are there, specifically DRDO laboratories. They have these facilities, and we have studied. Just they will what they will do it. They given training to me that in a toy. Then we did it exactly same for in a real. So we need to cut that one and just upper skin, and we'll put our material there, and then again restitch it first. After that, initial weight we have taken of that material, that particular animal, initial weight we have taken. Then every day we need to take the weight of that. So we will put it on this way, because the machine is in such a way that we no need to take that rabbit or that horse or that animal to weight it. The machine itself is that every day we can see the weight, how the weight is increasing or the weight is decreasing, or all these things. Here only one means information they are given to us. Other information is also there. One information they have given to us that if there is any type of chemical reaction will take place inside the body, then the weight of that animal will reduce it. The weight of that animal will reduce it. So that is the first. If there is no increase, one day the weight will not never increase. That today is 5 kg, tomorrow it is 7 kg, day after tomorrow it's 9 kg. It's not. There is no loss of weight. If there is no loss of weight, means it is not chemically react inside the body of that particular animal. It's not chemically react. So we have studied this through this means what we have observed that there is no loss of weight of that particular animal is there, no loss of weight. And the minimum time period is 7 days, and the maximum up to 15 days. Generally they are allowing us to study, and after that we have to remove that one. It may die after that or not, that also informations they are not giving to us also, or it may die in the next day also. But in our analysis after 15 days also, that day we have removed that material, we have observed that it was healthy. And after that we can't say, I don't know also what happened also that particular animal. So this is the biocompatibility study, the basic study, and it is the means a fruitful study also. You can say that if it is proved, you can study through different equipment that it is a corrosion resisting material, it is very good X, Y, Z through test, but through animal, let it is compatible and there is no further any type of reactions, then I can say it is 100% biocompatible. This is the study what we have prepared. And simultaneously, it's implant micrographs also we have taken. Unimplanted micrograph, how the blood cells distributions are there. Then implanted micrograph of series A, series B, and series C. All the series we have studied. And these through, we can say that whether there is any type of a chemical reactions is taking place or not. Minor reaction is there, it's not but there was no weight reduction of that material, is because obviously any material, if you put it some artificial foreign material inside the body, definitely some type of a swelling or some type of a reaction, some minor type it will take place, and it is a painful also. We are unable to understand and to measure the things. So what we did it, we combined all these biocompatibility, its a physical property, its a mechanical properties, its a tribological properties, because there is a huge number of data are there. So it is also not easy to, it is because in X case, maybe certain percentage of material is good. In Y case, some weight percentage of material is good. In other case, some other percentage. So in total, how can I say that at the end that my X material is the best? So for that, we have studied the multi-criteria decision-making analysis, so that I can say that at the end, my X material is best overall best as compared to other series. Nearly 14 to 15 series are there. So we have studied this, that base material filler with MO 1 to 4, then base material MO and nickel 1 to 4, then base material nickel, then 1 to 4 weight percentage of tungstens. These we have used, and we have studied that is a hybrid multi-character decision making analysis. I will show you the results only. That the criteria we need to decide it. You want density lower, you want hardness higher, so accordingly you have to mention it, that exactly you want hardness higher the better or lower the better. Similarly, compressive strength higher the better. Similarly, wear resistance lower is obviously better. Coefficient of friction lower is the better. That you have to decide it. Accordingly, this multi-criteria decision making it will work. It is a easy thing. It is easy. It is not that either Topsis technique, or you can say AHP technique, or you can say that there is entropy technique is there. That is there are a lot of nearly 15 to 16. There is a fuzzy entropy, fuzzy Topsis. All techniques are there. So through that we can say that, and this is the final the weight criteria. You have to use it also. But in a GA, the weight criteria generally we are giving that the specific input there is more weightage. Like a class have 20 students are there, then I can say, oh, someone will ask who is the best student. I can say that X and Y is the best, or I can say through by seeing the results X and Y is the best. So through by seeing the result X, Y, Z is the best is the logical. Similarly, the weight percentage, the weight criteria, what we have decided based upon the results only. What result? Through that only we have calculated the weightage of individual factors or individual outputs. So then we have studied, and finally we have observed that 2 weight% of W is the first one, is the best one only. That is the rank we did it through the hybrid optimization techniques only. And the rank 2 is again the same series, 4 weight percentage of W, the rank 2, and 1 weight% of W is the 3 weight% of means 1 weight% of W is the third rank, and means the W series gives better results. It gives better result as compared to other series are there. So it means that I have shown you the literature also. Most of the people cobalt, chromium, molybdenum, cobalt, chromium, molybdenum, or nickel. But W, cobalt, chromium, molybdenum, nickel, and W series was not. So we have studied this one, and we always, as a research, the basic should study first, along with your improved version, so that every time we can compare our modified version of result with the basic, so that I can say that my modified version is better than the basic or not. Not necessary every time, so we will say that our result is a good only. There should be some failure analysis also there. And we should study also failure, because most of my work generally we are going for failure analysis, because we will get more conclusion through failure analysis only. If it is a better, your thought process will stop there only. So we need to study the failure analysis of a jar. It means that crack or the fracture analysis of a material, so that you will exactly, or you can study the DMA analysis generally, so that we can say that our material is good or bad. This is another series of this is a basic series of our research in 2000, I can say 9, 10 and 11. We have started 13, 14, was completed just 4 years to complete this part. Then after that 3 more series is also there, but today I am not going to discuss that part. And I will show you that that another series, that the dental metal. We have dental wear simulator is there. So here the different generation is there. Just within 5 minutes I will complete this part. So just I want to show you that it is also feasible in our laboratory to study exactly how the human is chewing. That way we can chew it, and we can study it also. We have studied in a tobacco medium. We have studied in a deionized water medium. We have studied in a food slurry medium. We have studied in a means cold drinks, that is artificial cold drinks, that means that medium. So almost all the medium we have studied, and through that also we can predict that the artificial materials, whatever you will develop it, it is its life is for 5 years, 6 years, or 10 years, like this we can predict it, the life of that materials. And the chewing technique is uh, there are 8 different chewing techniques are there, starting from night biting to the sound, because most of the sometimes we have observed that you are along with your friends, while taking the foods, you will see that some type of sounds also you will see, you listen also. So this type of technique, so there are 8 optimization techniques are there, and best optimization technique is 8 only. If you write 8, that is exactly the best optimization technique for chewing of a food. Uh, and we never thought also 8 is the best optimization technique only. So generally the soft foods, whenever we are taking soft foods or the rice or all these things, they are soft foods only when you're taking. That time the chewing is the 8 only, symbol is 8 only, it is. So these are the different generations of the restorative tooth materials only. So there are one type of series of materials we have taken, that is a BIS DMSS, GMA and TEG DMA. There are a lot of and we have taken particularly nanomaterials also. And the real problem is this one. What the problem is that the upper surface or the side also. These are the general problems. Sir. It may be the problem is by continuous chewing of the tobacco, all these things, this type of damages. See these are the different type of damages which is taking places inside the in the mouth. And you can, so by using this, the we have studied that it's the materials whatever you have prepared, and if I will put it that material for artificial applications, then after 10 days or after 15 days or maybe after means 365 days, so it is it that material is sinking or not, because it is a polymeric material, regularly we are chewing, some load you are giving to that tooth also. So there is a sinkage is also there. Sinkage may be load, sinkage may be the, the food materials, whatever we are taking, that also it will means it will take some type of reactions inside the body and that tooth material, so that the sinkage is there. The sinkage also we have observed that is a nano alumina content. If you take it, the polymerization sinkage is 3 weight% of nano alumina is minimum. So that is exactly. Whenever you go to the doctors, they never will ask you that you want 3 nano alumina with a 3 weight% of sinkage or 2 weight%. All this is nobody. In general, they do. If you go to the dentist, they will ask you that the cost of that. If you use this one, it is 7,000. If you use this one, then it is a 3,000. If you want to use a diamond, it may be 5 lakhs. If you want to use a gold, it may be 2 lakhs. Like this, they will say that. And not a single dentist, they will show you, they will help you, they will ask you that the first prime duty of a dentist is they should ask your regular activity, your habit. What is exactly your habit? You are a vegetarian, or you are a purely non-vegetarian, or you are a mixed, or you are a smoker, or you are taking tobacco. All these things, it is means these are the basic only. They never ask you that do that. So last 4 5 years, Jaipur Institute of Dental, that is a government, they are working with us only. So these all are their original dental materials, and we have studied and given result to them also, along with our results. What new dental material we have developed, along with our we have given to them. Now we are studying that means after 15 days, some type of a chip we developed. It will put it that chip there only inside the mouth, and after and continuously you can see through mobile that the any type of a uh, twist is there, or any type of a sinkage is there, or any type of a damage. Everything you can see through result only, not the image. Through results we can see that there is a degradation pattern is there or what, that also you can do. So this is the present research what is going on through the masters of dentals, MD. They are doing masters program in that institute, and simultaneously they are doing the research along with us only. So this is FTIR analysis, that is Fourier transmission infrared analysis spectroscopy. Here we can see that what type of a bonding, that whether it is a C double bond C or C11O or SiO, Si, the materials whatever taken, what type of a bonding is there. Based upon that bonding, it is a, so we can say that it is a, the binding strength is strong, is a good or bad. That also we can predict through PIC. We can find out that it is a C11C or it is C11O through PIC, because PIC has specific range is there. Through that range only we can say that this type of a bonding is taking place. So generally the storage and loss modulus we are calculating. Because of that, in a we have given temperature also to that, because the maximum temperature for dental material, people have studied 120, 130 also. We have given 250, but we have observed that after 130 or 40, there is no improvement is there. It's a constant only. There is no. So through storage modulus, we have observed that starting from nearly 0 to, we have different 50 degree, then 100 degree. Then we have observed that after 100 degree temperature, there is a degradation of the materials is law. So it means that the material whatever I have developed, I can give a specific note to the patient also. I should give specific note to the patient that you should not take the food which is in a high temperature like tea we are taking. So you should avoid that. At least the ambient temperature only we should follow. So this is the indication of that the material whatever I have developed, I should say that after 75 variation starts. It means that it's a reasonable that up to 50. So it is the best suggest the patient so that he or she will know about or ever about the artificial tooth material what they have used in their own mouth. So that is, and through loss modulus also we can calculate it how the loss is maximum. So these are the pattern. Similarly, through thermogravimetric analysis, that's also that at exactly at what temperature, few of that NADC series it gives after 100 it starts losing, whereas other series are there, NADC 0, NADC 2, NADC 3, that series is nearly 220, 230, it is a constant, there is no loss in weight of that material, then it starts losing. So these are the different means test. Through that we can say that our material is fit for specific or not. Same compressive strength and hardness also we have calculated. And as far as nano alumina is concerned, nearly 2 or 3 is the not weight percentage of nano alumina, not major variation of as well as compressive strength, because dental material, hip material, both are the major input is significant input is the compressive strength only, as well as hardness. Obviously, both. If hardness is high, then you will get it also. The wear resistance also will get better. So this is the equipment what we have in our laboratory, and it will show that near below that you will see the white part, and it will just travel like this. How our chewing pattern is, so that we can analyze the things, and it is also temperature. We have chamber temperatures also up to 100 degrees centigrade. Our chamber temperature is also there. So with the food particles, whatever I will take it, that food particles also in what temperature? It is in room temperature, no doubt, because in a, or it may be in a 50 or it may be in a 60. That temperature also we can maintain also. And we have studied again same dry as well as the lubricating conditions only, the medium. And through wear analysis also we have observed that which material is good, which is bad. So NADC 3 series gives better result as compared to other series also. And this is the damages. In general, we can't see our, but if you go really the dentist and if you ask him or her that whatever the waste dental materials are there, you dental, that means tooth material is there, you just take it and do the microstructure analysis. You will see this type of damages. We never observed, we never thought also that this is a crack there, and it is failed because of this. So all these things we can see in a real artificial is a different, but in a real material you will see this type of a failures. It may be micro plying, or it may be some type of a because आप देखे होंगे those who are taking regularly chewing for tobaccos, all their tooth materials, you will see that the width of the height as width both will reduce only. Okay, so that is only because of the habit what you have, that is. So the main is that reason. So through that we can say these are the different type of failures are taking place. So there are huge number of results are there. Just an overview of our work I have, so means I am trying to showing you that so that you will know that. And this is the one of the observation is that at a 25-degree specific temperature, chamber temperature, 25-degree chamber temperature is a maximum loss. It means that we should avoid that. That nobody will give you idea. Not a single doctor, they will say that after replacement, after this prosthetic application, after doing the operations, they never say you that. They only say that 2-3 days, don't take a hard foods, so to take it some liquid foods. After that, it will all right. But if you don't have any idea, if you don't have any idea of that specific material, so unknowingly we will do all these things, and it will fail at the day. And your expectation is that it will work for 7 years, but it will fail after 2 years also. And it is not that easy that every time you will remove it and put a new dental material. It is not that easy process also. If you do multiple type of operations, then again there is a side effect is there. So this is the result that beyond 35, if I will go, there is no problem at all. So I have to avoid that one. 25-degree temperature is avoid. It is not that you will put temperature in a thermometer or some type of a device. Anytime you will take food, you will put it that device, then what temperature exactly it is. It's not like, in knowingly you will understand that things at 25-degree temperature is what, 35-degree temperature is what, and 100-degree temperature is what. That we can understand by touch the food only. So this is the overview of that only, the which gives this NADC series as specifically 3-weight% of saline treated nano alumina at chewing load of 40 Newton with a profile speed of 20% and chamber temperature of 15 degree exhibited minimum wear rate or high wear resistance only. With this, I want to stop my presentations, and now it is over to you, sir. If any questions you have, you are most welcome to ask me.
Thank you, sir, for an elaborative and exhaustive work on biomedical applications. So you are working only with metals or polymers also, sir?
Polymer also, both I am
Both.
working. That's why one hip part I have shown you metals, and dental part I have shown you the polymer. But we are working both metal and polymer.
Okay, fine. Okay, now the forum is open for discussion. If you have any questions, you can ask actually, please.
Sir,
Yes, sir.
one question, please. In the dental cure, is it possible to deposit the polymer material directly on the tooth, decayed tooth, what we did in metals cladding or something like that? I know there are many restrictions, maybe because of we have to work on the biomaterial, actual natural biomaterial on the mouth. But
Yes,
is
sir.
that is it any possibility or any work has been done so far, or they not yet done anything on that,
No,
sir?
no, people
I just want
people
to
do
cover.
it, sir, but in means if you because last you can say that 10 years I am working this one. If you truly, if I want to say that nobody is working perfectly, sir. कोई कर दिया
Okay.
5 मिनट 2 पेपर कर दिया, वो अपना काम खत्म कर दिया, वो अलग है. बट इन डेप्थ एनालिसिस till date I am saying you that I am working the same series Just a slight variation. Last 10 years, I didn't get any conclusion, sir.
Okay, okay.
Reason is that every time it is changing, every time, because biomaterial compatibility in animal basic analysis, but when you will put inside the human being, totally
Yeah, yeah.
different. I will put
Yes,
in,
yes.
like I will put in my body or in your body or someone, it totally
Yes,
different. It's
that's
it's the biggest problem. And then people don't like also. Let there
yeah,
someone is above 50 or 55, they don't
yeah.
like to do this type of
Such
operation
type of
because
thing.
after that
Yeah,
100% cancer is the side effect, sir.
right, sir. Okay, sir. Thank you. Thank you.
Okay, sir. Okay, sir. But these facilities is our laboratory and we are doing continuously. I don't know when we will reach, and we should not reach also. If I will reach the somewhere and it is absolute, then I means nobody will do next. So that's why every time we are trying our best. It means every 5 years I'm giving at least two students. One is dental and one is others we are giving. And as I have guided 25 PhDs, and then out of 25, 10 PhD students are this prosthetic and dental only. 5 5. So every 5 years, I'm giving one group to dental and one group to prosthetic. And they are doing, sir. Now we are doing simulation of that. But because every time formulation of this problem and preparation of this composite, nearly 2 to 3 lakhs, sir. You know it, the NIT system. Ah, nobody will give that much money. So it is better to go for some simulation analysis. So if you have some projects, then it is good. Otherwise, take money from institute and do all these things. Anywhere it is, any institute, it is a tough. So now we have studied that experimental analysis with simulation also. So that maximum to maximum we can study through simulation analysis. That is ANSYS Autodyne we are doing.
Okay, thank you, sir. Sir, there is one more question there is one Ajay Ravindra Bharadwaj want to post a question.
Okay, sir.
Ajay, you can ask it.
Sir, I have questions. Hello.
Yes, 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 please.
Sir, my name Ajay Bharadwaj from Jalgaon, Maharashtra.
Yes.
Sir, nice to listen your presentation. It was very, very knowledgeable.
Thank you, sir.
My
Thank
question is that, sir, you have fabricated the material matrix composite
you.
by which method, sir? Stir casting is suitable for.
We have through vacuum steel casting technique, centrifugal steel casting technique.
Sir, you have selected some process parameters, the temperature,
Yeah.
the
That is
rotation
through
of the
literature
stir.
only, sir. It's not our own. Through literature only, that things we have finalized. Material is no doubt it is new, but the combination, all these things, because if I will put titanium instead of 4 weight percentage, if I will put it at 7 or 8, then 100% it will brittle. There only it will fail a single stroke only. So that also we need to see that up to what extent. And the American Orthopedic Association have a series also, sir. You can download from website Google. It is available that all the elements maximum up to what extent you will go. They've given, sir. They've given. Based upon that, if you will move it, then it will helpful. Some, no doubt, they have not studied all, but they are sure that if I will go with a titanium or vanadium or chromium or moly or alumina, so up to what percentage if I will move. If it is alumina, then I can go up to 65, 70, 80%, no problem. If I will go titanium or nickel or tungsten, 4% is maximum. People have studied up to 2.53. I have gone to up to 4. So all 4 my results are inferior results only. I have observed nearly 3-8% shows better results.
Okay. Okay. Thanks a lot, sir. Thanks a lot, sir.
Thank you, sir. Thank you, sir. Thank you, sir.
Any other question, please?
Yes, sir. This is Anand Ronald from SSN College of Engineering, Chennai.
Okay, sir.
Nice presentation, sir.
Thank you, sir. Thank you.
You told about hip processes corrosion studies, right? What is the corrosive environment you are talking about?
Here,
What was
corrosive environment is means
Sodium.
some liquid nitrogen medium is also using, and other medium is also there, and they have specific laboratory. They have specific type of medium is there. It is your choice which medium you want to start. Okay. So because there is no specific what reason this corrosion will take place, so there are generally one or two that. So in general, NaCl also you can study, or you can study the liquid nitrogen medium is also, or argon medium. It depends, sir. You can study any medium.
Okay. Should it not match with the body fluids composition?
No. Body fluid is different. Corrosion is different, sir.
Because heat processes means body
Body
fluids
fluid
will
is 100% in contact with that, but that type of that corrosion is different. And here the corrosion what we have studied is a life of that material. Here corrosion we have studied life of that material inside the body.
Okay. And rats, you did some implant.
Yeah.
Are there any ethical clearances we have to get before we
Yes,
do
sir.
such
1 lakh we need to pay first.
1 lakh. Two?
1 lakh rupees we need to pay. It is a DRDO laboratory, Gwalior, and other laboratories also there. We studied one of the DRDO laboratory. It is
No,
a
from
very
whom
good
you have to get clearance?
No, that DRDO itself will give all this. That is their job. They are accredited. No, that is their job.
Okay. And
We have to pay that fees. So rest is their job only. It is nearly 1 month process, and after that they will call you. You visit there. Initially they give some training with a toy. Then you have to study with the original.
that cutting also you only have to make, sir?
I only did it. This is the Amar Patnaik only. This is the fingers.
Okay.
You can see.
Because it's like operation. That's why I'm asking.
It is like operation. Means initially in that toy, I felt slightly means bad because we are not that much crooked that we can cut. Then the other people said that no, don't feel like this. It is part of our job only. So you can do it, no problem. Because I am a vegetarian, so they said no problem, you can do it.
The definition of doctor and doctorate, you have made it actually.
But sir, but I'm proud why I can say that not in hip part about dental part, the even doctors, dental doctors, every week at least 3-4 doctors they are visiting in our laboratory, sir. So that time we are feeling proud that as they have studied 5 years in doctor's degree, still they don't have this basic knowledge, sir. No doubt they have knowledge their own about medical, about medicines, all these things. But I only suggest them whenever a patient will come to your door, no, you ask first what is your habits, what the habits you should write first. Then you suggest him with this habit, this material only fit. Don't go for I have 7,000 sir. Put this polymer. He is a hard and core tobacco person. You will give a polymer dental material to him. 2 साल के बाद वो polymer और वो tobacco दोनों मिलकर अंदर चले जाएंगे.
Correct.
Then again it is a big effect. The seeds are tobacco has side effect, but after 10-15 years or 20 years. But the dental material will go inside, no? It will take hardly 2 years to come to the conclusion that you are suffering with a cancer.
And the rat, you said weight loss you are measuring in order to know whether it is creating any unwanted effects in the rat.
Yes.
Is there any way by which we can know the comfort level of the rat, whether it has any pain or?
That they are identifying, sir. That they are identifying. They are putting some type of a chip in their. आप मैं वो दिखाए वो पार्ट हम लोग नहीं दिखाए आपको. वो जनरली ईयर में एक चिप वो प्रेस कर देते हैं. So through that they are whole day they are observing their food activity, all these things they are observing.
Okay. Thank you.
That part I have not shown, sir, and it
Okay.
is slightly different. That part I have not shown. Only
Thank you very
upper
much.
part I have shown you.
Okay. Thank you very much, sir.
Okay, sir. Okay, sir. Thank you, sir.
Any other question, please? Fine. So if nobody having any question, let us thank the speaker. Sir, we can have a photograph with you. Let
Sure, sir.
everyone see
Sure,
your
sir.
videos on. We'll have a photograph. Prayag or Nikhil, they can take one snapshot.
Yes, sir.
रख दीजिएगा हमको सर आएंगे तब ना। यही दिया है
Yes.
Yes, sir. Done.
Prayag, you can take now.
Yes, sir. Done.
Taken.
Yes, yes. Done.
Okay. Thank you, everyone. Thank you for the wonderful session, sir. And it is like a going back to earlier they used to say, no, you can do M by PC. You can do maths and you can also do by PC. So you should have done that one also. That correct. Thank you very much, sir. Thank you all the audience. And
Okay, sir.
again, we are
Okay,
going
sir.
to meet at 11:30 for the last session of this Material to Manufacturing 2021. And that will be the last session of this 5-day workshop. And let us thank the speaker once again. Thank you very much, sir. So we will keep in
Okay,
touch.
sir.
And
Namaste. Namaste,
maybe
sir.
if some students have any query, I will share your mail ID with them. If they
Sure,
want to
sir.
use their facilities, you are requested to welcome them.
100%, 100%. No problem, sir.
Okay,
Okay,
sir.
thank you, sir.
Thank
Bye
you very
to
much,
all.
sir. Thank you, sir. Thank you. Bye, sir. So, participants, I'll stop here this session.